impact and quieter conditions. It's here, yeah. Yes, there's something wrong and so but with this part is not a problem, generally it's really written. Yes, I like to my outlines today. First of the short introduction, I give some information about the original text, but I come to the main part of my talk, results using the instrument and sharp input tests and finally the structure behind that and I go in position and finally the next summary talk. Yes, can you know that some years ago, the polymers starts having prototyping and later having tooling for anamorphic insects. But now it's very important manufacturing. Probably using manufacturing to using different approaches. Maybe this powder-based ones, the extrusion ones, and the liquid ones. Using that because it's generally possible to produce one part or the small scale production within initial applications. And compared to very known processing, such as injection molding, you have that's cost saving and time alternatives, and then you can also relate it to this design, so you can produce parts to very experimental applications. But there are some disadvantages, and up to now, especially polymer materials, the only very knowledge about chemical gas behavior and long-term mechanical property related to the crack of such activity manufacturing polymer parts up to now. So we have to strain there our work. Yes, what we did there, we produced different samples, but we doesn't use PLA, we use other materials, and we focus on ABS, on polycarbonate. We're using such zinc personnel filter for cooling. And why are we using that? That's two things. First of all, they have a heating platform and a heating building chamber, and other very important part is they are open related to the hardware and software. They are very useful to make some research on that. And yes, first of all, this is a very important point. If you have a new material or the materials are not very used for manufacturing, you have to take into account a long-term optimization process related to the parameter, linked to the structure, linked to the quality of processing. And this is very important, not to use the parameter they are given from the producer of the machine or the materials. So if you come to real application, you have to optimize first the parameters. If you do so, then you can play with these parameters as well. And we using different parameters. I show them here. Some parameters, the speed has to be right in our case here, and our notation maybe 50, 45, 45, and 90, 90. We're using the full in-file field as high as possible, but yet you can use also inline structures. It's very useful because to have the time is less. The time is less than. But we're using our parameters too, but they are not part of my talk today. Yes, and if we do so, we can prepare such samples with high qualities of small size compact tangent specimens for the mode 1, but also for the mode 1 and 2, and all the other different samples for fluid mechanics and mechanical uses. And now we come to the intensity test. Mostly, if you look into the literature, you found that the most results they are obtained only related to the tensile test. So if you do so, you find, yes, it looks well, you have no big changes compared to the processing parameters. They look always the same compared to the elastomodulus or the tensile strain, maps for the PET and the ABS. Maybe it's a little higher, maybe for the 1990, it's a little higher, but this does not matter. But you're using all the comparison moldings as comparison for the same materials. Clearly, due to the porosity, they are a little higher, of course, but in general, it looks fine. But if you finish the version here now, you cannot say that's used for the real application or not. You have to do practical mechanics measurements to it, which shown in the next slide. If you use it in the tensile test, yes, that is for maybe for the ABS shown here, if you have the speed of 1 meter per second at room temperature, if we find such a diagram in other cases if using ABS. It's the same for injector molding, the same for the manufactured here in that case, also, but also for the compression molded samples. You have always the same sample. This is very surprising because that's a little bit far from the case if you're using PLA. They are really brittle, but for ABS they are not brittle, so they're more advanced to use for the applications. As you can see here, you have a plastic fracture, plastic information, a little bit of instability, Daniel calculus, and a high amount of stable crack propagation. And but you can use the well-known approaches of J and CDD. You have to take into account some light microscope analysis of the fructoscopes to give some information about the propagation mode and all the information about the stable crack propagation as well. We do so, and clearly this is not a surprise, but it's very nice. That's clearly the internal structure has a high effect on the crack mode. You can see it's exact information. If you have an external loading of mode 1, you have an internal mixed mode, mixed 2 state, and the high classification is seen in the clear stress widening. If you have maybe 90 degree orientation, you have the mode 1, and maybe you know it from the general way of fracture mechanics. That's both two portions have a higher effect on the fracture toughness, so it gives higher values. And this is also very nice because if you have infrastructures, you can make the structure in such a way that you can optimize not only the mechanical behavior, such as the strains and the tensile strains and the modulus, but also the toughness at the same time. You can see this clearly to the values, clearly under 45, we have higher values than compared to 0.90. The catch speed doesn't affect as well. And that's not so clear for polycarbonate, but this is for volatile, but compared to the ABS. Very nice is to see that the compression molded samples gives more or less the same values, especially if you have the 45. But for PVC you have no correlation between the compression molded samples and all the other manufactured. Next point will be static fracture mechanics. What is shown now was those starts in stable crack propagation under impact speed. Now I give some information about the test at qualitative loading conditions. One of the approaches very available in the literature and used by myself very often is the so-called method as a conversion fracture. Generally using such double knot specimens and fulfill such requirements. Maybe the technical station have to start after plastic of the ligament. Certainly the load system can have you fulfilled in the state of penetration with the tube. You cannot light it. This has been done for materials for ABS and for PC. This works well for ABS and less well for ABS and less well for polycarbonate. Yes, if you do so, you can plot the specific block of flux as a ligament length, and the slope here gives you information about, or it's a measure the distance against stable crack propagation, and the onset is so-called special block of fracture. The S-cell fracture gives you information about the distance and crack initiation. And the same, we will see it here in this. How do we do some image correlation? But for the crack resistance curve measurements, we have done this too, but it's not a part of my talk today due to limited time. We can see here such straight field buff scales. Clearly, if you have a 0.90 degree orientation, we have a very clear one mode direction of the crack. Not the same, but it's not the same. 45, you have a clear mode 1, mode 2 direction of the crack. Is very clearly seen in the isometric plastic zone. Same is if you look into the vertical fractures of functional ligament length, you see the two different parts of the slopes. The highest slopes are related to the 45. The lower slopes are related to 90 degree orientation. And clearly there's no influence on the crack speed as well in different range, but also for lower speed. And this can be seen in the values as well as the cake propagation and cake initiation as well, as we have the same behavior more or less compared to the impact test conditions. Yes, now I'd like to summarize my talk today. Yes, a scene does no, this given range, but over lower speed does no influence of the printing speed. You can use as high as possible. And clearly, the mechanical medium instantaneous is more that's always the same. We can say a little higher for the 90 degree if you look into the tensor range and the modulus. But very important is that due to the structure, of course, they have higher values to the 45. If you look to the fractal mechanics values, buffs at impact and binomial projects, buffs related to the resistance and unstable cannibalization, but also to the resistance and stable and cannibalization stable cannibalization, stable propagation. The reasons clearly as seen in the pictures and also in the digital image correlation. And we have a clearly part here of the mode 2 function, and mode 2 gives a higher value toughness than mode 1. And clearly we found that ABS is very, very useful after a homologation process, much more than compared PC, and I think also more to PLA for such particle application. Yes, and now I finish my talk. I have to give some thanks to the field support of the Grellmann of Saxony-Anhalt, and I thank you very much for your interest. I hope
Thank you for your nice presentation and in-time presentation. Very nice. Any question, please?
Did you measure your mechanical properties as a function of test rate, not the printing speed?
No, the test rate is also changed because you have because 1 millimeter per minute is quite a crystal and 1 meter it's an impact crystal. We did it not for this. I did a lot of work before in ABS, so we did it too in ABS too, and also polycarbonate and changed also the speed. But this was not part of this work. But we did. I did it by myself very often to change the speed, both at impact conditions, but also at critical. But clearly you see an effect, but you have to take into account that the change in fractal mechanics is related to the logarithms of the speed changes. So you have to change it by a logarithm, not in a linear scale. Yes.
Okay. Thank you.
Yeah.